In this video, I want to go through normalization process. I have a table and I want to know that if my table is in one of the normal forms, if it's not in the normal form, I want to normalize my table until third normal form. Um, okay, let's have a look on this table. And this table includes information about the employees and their working projects, and those projects is relevant to a specific department, and the finally working hours of those employees on their projects. Okay, we have employee ID and their full name and their birthday, information about the project that they are involved, project ID, project name, the start date and end date of the project, and we have information about the department, department ID, and department name. These are the finally working hours of those employees in the project. And we specify the data type of each field, and we can have a look at the data as well. We can see, for example, employee ID 100, Jack Smith, birth date, and he's involved in two projects. Then these project names are ADT and DRTs. They have a start date, end date, and some other information like the department's ID and department name and their total working hours on this project. Okay, um, to check normality, before checking the normality, we can have a look at the anomaly problem that we might have in this table. As you can see, we have two rows corresponding to Jack Smith, and Jack Smith may have many rows in this table because Jack Smith may be involved in different projects, and that's why he might have 100 rows, let's say, in this table. um, we have an update, for example, anomaly, and it means that if the birth date of this employee, Jack Smith, is changed to something else, we should update all the rows corresponding that full name and that employees, or the full name, for example, the last name of the employee or the first name of the employee um, is changed to something else, then we should update all the 100 rows corresponding to these employees. This is called update anomaly. Another thing is about the delete anomaly. It means that uh, for any reason, if you remove all the rows corresponding to, let's say, Mary Taylor rows, all the information corresponding to date, department, for example, or projects will be removed from my table. So I don't have access to those information in my table. Okay. The another anomaly that we have is about the insert anomaly. If we have a new employee, but the employee is not involved in any project, we cannot insert information about that employee in my table until that employee is involved in a project, and afterwards we can insert the information of the employees into the table. These are the different types of anomaly we might face if we do not normalize our table. Okay, so let's check the normal forms of this table. The first normal form says all the columns should be atomic and should not be multi-valued. It means that in each column we should have only one value. We can see employee ID is 100, which is fine, but full name has multi-valued information, right? Jack Smith, first name and last name of the employees. Okay, We have birth date. Birth date is fine. We can consider dates in our table as atomic column. And we have project ID, project name, and other information like department ID is fine, department name is fine, working hours is fine. So the only problems that we have is full name, because if we want to find information about the first name of the employees, we might have some complexity, for example, or we should write a program, for example, to change something in our tables. It's better to make this field atomic. To do that, we can create two fields in our table. We call it first name, which is varchar, and another thing is last name. Again, we consider varchar, and we save that information, and then we can enter information about the first name of that employee, like um, Jack for this one and Mary for the other one, and we have the last name of these em- employees into the table. Okay, when we have that and when we apply this information, then we can remove um, the full name from the table. I apply that, and when I go back to my table and I see the values of this table, let me run it, and we don't see the full name here. Instead, we can see first name and last name. So our table is in first normal form. Let's check the second normal form. The second normal form, it says that all the non-key should completely dependent on the primary key, not a part of primary key. There shouldn't be any partial dependency. It means that all the non-key columns, like for example first name, last name, should not dependent on part of the primary key. What is primary key? Employee ID, project ID, and start date. It means that in our table, one employee can be involved in the same project but in different time, right? So let's start with each field in our primary key. Employee ID. Employee ID. For employee ID, we have birth date and first name and last name. All of these three fields are dependent on employee ID. So this causes an issue. This is partial dependency. So we should remove these fields from this table, first name, last name, and birth date, and create another table named employees. I created another table named employees, and that employee includes employee ID, first name, last name, and birth date. Okay, and I enter information about those two employees in the new table. So it's safe to remove information about those employees from my actual table. Okay, from here I remove birth date and what else? First name and last name. Okay, so that's good. Uh, we keep the employee ID here to connect this table to the actual table, to the um, employee table. And employee ID will be here a foreign key, and at the same time it is part of our primary key. Let's go forward to the second field, which is project. And as you can see, we have some other non-keys like project name, start date, end date, that they are all dependent on um, on the project, right? So for that case, we can create another table for project. I created another table for project, and that project includes project ID, project name, start date, and end date, right? For that case, I entered all the information about the projects in the new table, but in actual table in project ID, project employee project, I can keep the I can still see the birth date and probably first name and last name because um, I didn't save that. Yes, and for project I can remove the project name and project end date. At the same time, I can remove the project start date as well here. Now there's a change on my keys because these two cannot be primary key. Probably I should have another field for primary key. At the same time, I can see that, for example, I can consider here employee project ID, and it can be integer and it can be auto number, and this auto number auto increment, um, I apply this, and when I insert the information I can see that I I have a primary key employee project ID. I have employee ID here. Where are the information about the employees in another table? Okay, and we have project ID here. Where are the information about the project IDs in another table again? And the other are fine, so I can see that this table is in the second normal form. Okay. At the same time, um, I can mention that those fields are foreign keys, right? Even here, I can mention that I have a foreign key here, and it refers to employees, and employee ID in this table is foreign key. Another one, project foreign key, and it refers to project through project ID. It should be fine here. Yes, and yeah, that's it for second normal form. In the second normal form, I can see the final table is these two are foreign keys, and we have a primary key, and all of these fields are dependent on the primary key. Okay, for the third normal form, all the keys or all the non-keys in a table should be independent from each other, and all of the non-keys should be dependent on the primary key. This table is in second normal form but not the third normal form because we can see department name is dependent on department ID. So this dependency, we call it transitive dependency, which means that um, department name is dependent on department ID. At the same time, department ID is dependent on the employee project ID. So department name is transitively dependent on the primary key. This is a problem. I create another table for these two columns. We call it department, and I insert information about the department here. As you can see, we have department ID, department name. So now it's good to remove the department name from this field from this table. So I remove that, then I apply these changes, and now this table is in third normal form. At the same time, I can have a department foreign key, and it refers to department, and this the same as department ID. It should be okay, yes. And now the table of employees um, have less columns, but it is in third normal form.